Hello everyone, and welcome to a session of equations in isolation. So you guessed it, we are going to be looking at equations now. We're going to be doing a little bit of a revision on what we've been taught during this first term of work. So what we're going to start with is linear equations. Now with linear equations, we're going to have a sort of an order to solve. Alright, and what we're going to be looking at first is we first want to separate the variables onto one side and the constants onto the other side. Then we want to use inverse operations, so that means moving our number across the equal sign and changing the signs. And then we're going to simplify our like terms, and then after that we are going to solve. So if we look at our first example over here, now each of these examples that we're going to be looking at now is in relation to a worksheet on equations, which I will link in the description of this video. So what we're going to do is we're going to keep the 2x where it is, and then we're going to say equals 2, keep the negative 4 where it is, and then we're going to move this negative 6 over. So we're going to move this negative 6 over, and when it moves over the equal sign, it changes its sign. So it goes from being a negative 6 to a positive 6. Now that is my inverse operation. Now once I've got that moved over, as you can see, I've got my x's on one side, and I've got my constants on the other. So now what we're going to do is we're going to tidy up. So we're going to say 2x equal 2, and we're going to add up our like terms now. So negative 4 plus 6 is going to give me positive 2. So now that we've got 2x equal to 2, we need to solve for x. Now how we're going to do that is we're going to divide by the coefficient of x. And in this case, 2 is the coefficient. So we're going to be dividing by 2 on both sides. So 2x divided by 2 is going to give me just x. And then 2 divided by 2 is going to give me just 1. So x equals 1 is my final answer. Now what we're going to do now is we're going to do a check quickly to see if our answer is correct. So what we're going to look at is we're going to look at the left hand side of my equation, which is the 2x minus 6, and then the right hand side of the equation, which is the negative 4. So in the place of x, we're going to substitute our answer into it, and our answer that we got was 1. So now we open it up. So 2, open up our bracket, 1, close our brackets, minus 6, and we're going to keep that negative 4 on the right hand side there. So 2 times 1 is going to give me 2 minus 6. I'm going to keep that negative 4 there, and 2 minus 6 is, in this case, equal to negative 4. So we have negative 4 on both sides of the equation. So therefore, left hand side equals right hand side. And we have just proven that our answer is correct of x equals 1. Now let's move on to a different example. So we're going to keep our 4x where it is. We're going to keep our 3x where it is. So that's plus 3x. Okay. Then what we're going to do is we're going to move this negative 5x over. We're going to move this negative 5x over, and its inverse operation will cause it to change into a positive 5x. So we are moving that negative 5x over the equal sign, and as we are moving it over, it is changing from a negative to a positive. We are then going to have our equal sign. We're going to keep the 20 where it is, and then we've got our positive 14 that we are going to move over. So our positive 14 is now going to change over to a negative 14. Okay, so now as you can see, we've got our variables on the one side and our constants on the other. So now all it comes to is consolidating our like terms, so adding or subtracting our like terms together. So in this case, we've got 4 plus 3 plus 5. Okay, so 4 plus 3 plus 5, which should give me 12x equal to 20 minus 14, which is going to give me 6. Okay, then you want to divide by your coefficient of x again. So now we want to divide by the coefficient of x, which is going to be 12, and divide by 12. Okay, so 12x divided by 12 is going to give me just x on its own, and now 6 divided by 12. Alright, 6 divided by 12, as you can see, is not going to give me a whole number. So what it ends up being in this case is I'm actually going to have a fraction, and in this fraction I'm going to have 1 over 2. So my fraction that we're looking at is a half. So x equals a half. What we're going to look at now is going to be still linear equations, but with the addition of brackets. So with the addition of brackets, we first want to solve the equations with brackets, but we do this by removing those brackets first. So to remove those brackets, we have to use distribution. Then after we've distributed, we are going to follow the exact same rules as before. So if we look at this first example over here, so my first step is going to be getting rid of my brackets. So how do I do that? Well, I distribute in. Now remember, when you're distributing, you need to distribute to everything inside the bracket. Not just the first term, but both terms inside the bracket. So firstly, we're going to go 3 times x, which gives me 3x. Then we're going to distribute that 3 onto the negative 4. Don't forget the sign that's attached to that. So 3 times negative 4 is going to give me negative 12. Plus 5 equal to x plus 3. Now, what I want to do here is I want to just consolidate quickly before I move everything over. What I want to do is I just want to say 3x, and then I want to tidy up my negative 12 plus 5. Okay, so my negative 12 plus 5 is going to give me negative 7 equal to x plus 3. Now that I've got that, I can move over my variable and my constant to the respective sides that they belong. So I'm going to keep the 3x where it is. Then I'm going to move this positive x over, and when I move that positive x over, it becomes a negative x because of the inverse operations, equal to, I'm going to have my positive 3 where it is, and then when I move this negative 7 over, it's going to become a positive 7. So now I want to consolidate my like terms, so add them up. 3x minus x is going to give me 2x. And then I'm going to have 3 plus 7. Yes, you guessed it. It is 10. Now I want to divide by 2 on both sides, because we remember we want to divide by the coefficient of x. So 2x divided by 2 is x equal to, and 10 divided by 2 is 5. Alright, we're looking at another example over here. So what we want to do is we want to get rid of that bracket first before we do any shuffling around. So we're going to start it off. So 2x, then positive 3 needs to be distributed into both of the terms there. So 3 times x is plus 3x, and 3 times negative 2 is negative 6. And that is all equal to 4. Now, remember what I said before, I want to just consolidate first before I do anything else. So 2x plus 3x is going to give me 5x minus 6 equal to 4. Now what I'm going to do is, as you can see that's formed now, is a linear equation with only one variable on the one side. So that's great. So I'm going to move this negative 6 over. So I'm going to have 5x equal to the 4. And that negative 6 that moves over changes its sign to become a positive 6 because of inverse operations. Now I'm going to have 5x equal to 10. Divide both sides by the coefficient of x, which in this case is 5. So I get x equals 2. So x equals 2. I've put up some examples in the textbook that you guys can tackle if you are feeling the need to expand this above and beyond the worksheet that is created. Remember, link's going to be in the description. Alright, so now we're going to be looking at equations with fractions. So still linear equations, but now we're going to be adding the addition of fractions. Yes, and I know this is everyone's favorite topic. So strap in tight, we're going to get going on these. So when solving fraction equations, the following steps are required. So we need to find our LCD, lowest common denominator, and then we need to multiply both sides of the equation by the LCD. So let's look at this one. Alright, so what I always say to my kids is that we want to make sure everything is a fraction to begin with. So I've got x over 4, and now I've got 2 over 1 and 7 over 1. which makes it a little easier to find my LCD. Now, I cannot make 4 become 1, all right, but I can make 1 become 4, which therefore means that my LCD for this one is going to be 4. Now, what I need to do next is correct the numerator for those that do not have the LCD of 4. So that means that I need to times this denominator by 4, and what I do to the bottom, I need to do to the top. Then I need to multiply this one by 4, and what I do to the bottom, I do to the top. So now, once I've got the steps, I'm going to have x over 4 plus 8 over 4 equal to 28 over 4. Now, once you've got them in a fraction form like this, we actually are going to, I say drop, inverted commas over here, drop our denominator. We are actually going to be focusing on the numerator right now. So that means that we're going to essentially be getting rid of our denominators. So when we rewrite the equation, we are going to have x plus 8 equal to 28. So now we're not dealing with the fraction anymore, we're just dealing with the numerator portion of it, which is going to be x plus 8 equal to 28. So what I want to do is I want to get my variables on one side and my constants on the other. So I'm going to be moving this positive 8 over and changing it to a negative 8. So I'm going to have x equal to 28 minus 8, which is going to give me an answer of x equals 20. So let's just double check ourselves here, and we're going to do the left hand side, right hand side. So we've got x over 4 plus 2, and then we've got 7 on the other side. So now we're going to substitute our x with the answer that we got, which is 20. So we're going to have 20 over 4 plus 2, and we're going to have 7 on the right hand side. Now 20 over 4, hopefully you can do this in your heads, is 20 divided by 4, which gives me 5. And 5 plus 2 over there, and that's all equal to 7 on the right hand side. So now 5 plus 2 is 7 as well. So therefore we have left hand side equaling right hand side. So x equals 20 is my final completed answer. Now moving on, we're going to be looking at a bigger fraction. So now, first step is we need to find our LCD. So now we've got 2, 3, and 2. So we want to look for the lowest common denominator here. So 2 cannot become 3, 3 cannot become 2. So in this case, we look for the number that they share in common. 2 multiplied by 3 gives me 6. LCD is going to be 6. For the first one over here, 2 needs to be multiplied by 3. And what you do to the bottom, you do to the top. So I need to multiply this one by 3. Then 3 over here needs to be multiplied by 2. What you do to the bottom, you need to do to the top. And then my last one over here, 2 again, needs to be multiplied by 3. And what you do to the bottom, you do to the top. So now, what's going to end up happening is I'm going to be forming some brackets. So on the outside here, I've got 3 open brackets, 2x minus 3. Then I've got plus 2 open bracket, x plus 1 equal to 3 open bracket, 3x minus 1. Okay, so now in this step, I've already gotten rid of my denominators. Okay, I've already gotten rid of my denominators because they are all equal to 6. So I've gotten rid of them, and now I'm just working with my numerators. So I'm going to distribute my 3 into the first bracket, I'm going to distribute my 2 into the second bracket, and my 3 into the last bracket. So 3 times 2x is going to give me 6x. 3 times negative 3 is going to give me negative 9. Then I'm going to have positive 2 times x, which is going to give me 2x. Then I'm going to have 2 times positive 1, which is going to give me positive 2. That's going to be all equal to 3 times 3x, which is 9x, and then 3 times negative 1, which is negative 3. Now I want to consolidate my like terms on the two sides. 6x plus 2x is going to give me 8x, and then negative 9 and positive 2 is going to give me negative 7. And that's all equal to 9x minus 3. So now I want to make sure that my variables on one side and my constants are on the other. So what I'm going to do is I'm going to move my 9x over, and I'm going to move my negative 7 over. So I'm going to be left with 8x minus 9x equal to negative 3 plus 7. So 8x minus 9x is going to give me negative x, or negative 1x. Please feel free to write the 1 there if you aren't happy with just writing the x. Then equal to negative 3 plus 7. So negative 3 plus 7 is going to give me a positive 4. Now we don't want a negative variable over here. So what we're going to do is we're going to get rid of that negative variable, which is by dividing by negative 1. And what we do to the one side, we have to do to the other. So negative x over negative 1 gives me positive x equal to 4. So positive 4 divided by negative 1 gives me negative 4. And our answer over there is going to be x equals negative 4. Alright, so now what you could have done is you could have actually moved things around. So if we look at this step over here, from here, if I decided to move the 8 across instead, so if I decided to keep the negative 7 where it is, move the 3 across, so negative 7, then I'm going to have plus 3 equal to 9x minus 8x. So negative 7 plus 3 is negative 4 equal to 9x minus 8x, which is equal to x. And as you can see, you've got negative 4 equal to x, which is exactly the same, x equal to negative 4. Alright, and then the last thing that we're going to be looking at today is using equations to solve word problems. So, translating the English language into the mathematical language. So firstly, we have a real life problem that we're going to be given, and then we need to convert it to an equation, and then we need to have a solution to the equation. So what ends up happening is we need to identify the unknown and translate. So this is taking our real world problem, identify the unknown and translate. Once we have that, we get our equation. Then we need to solve the equation, which leads us to the solution of the equation, which then can translate back and check that it makes logical sense. So the example that we're going to be looking at now is we're going to look at the sum of 3 consecutive numbers is equal to 276. What are the 3 numbers? So firstly, we need to break down what language is being used here. So the first thing that brings in my attention is the word sum. Okay, and then the second one is the word consecutive. Okay, so sum means that we're going to be looking at the addition of numbers, and consecutive means that they follow one another. So consecutive numbers would be 1, 2, 3. Alright, so we want the sum, so the addition of 3 consecutive numbers, and it has to equal 276. So what we want to do is we want to translate this, we want to find out the unknown. Okay, and the unknown is one of these 3 numbers. That's what we're going to focus on. So what we're going to do first is we're going to say let x, okay, you can use any variable number, any variable letter here. So let x equal, and in this case we're going to say a certain number. Okay, and that certain number is going to be one of the 3 numbers involved in this equation. Alright, so if we're looking at consecutive numbers now, so our first number in this case is x. Then our second number has to follow on. Alright, so it's going to be x as well with the addition of plus 1. Okay, so we're going to have x as our first number, then our second number is going to be whatever x was plus an additional 1, and then our third number is going to be x plus an additional 2. And that's going to be all equal to 276. Alright, so we've got our first number over here, our second number over here, and our third number over there. And that all equals to 276. So now what you want to do is you want to consolidate your like terms on the one side, and then you're going to solve like you would normally. So we've got x, x, and x, which gives me, if you add them all up, 3x. Then we've got 1 plus 2, which gives me plus 3. All equal to 276. So now we've just got ourselves a linear equation like we would normally have. And what we want to do is we want to get our variables on one side and our constants on the other. So we want to move that positive 3 over. So we're going to have 3x equal to 276, and plus 3 becomes negative 3 now. So we have 3x equal to 273. Now we want to divide by our coefficient of x, which in this case is 3. So we're going to get x equal to, now you are more than welcome to use your calculators here, but x in this case is going to be equal to 91. Alright, so x is going to be equal to 91. And when we're dealing with a word equation, we want to always finish it off with a conclusion. So therefore, the three numbers are 91. Then if we look at our second number, whatever x was, plus 1, which will make it 92. And then whatever the third one was, which is x plus 2, which is 93. So my three numbers that I'm going to be looking at here are 91, 92, and 93. 9.9, page 142, numbers 1 to 6. Alright, so that's all for today, guys. So be sure to check out that worksheet that's in the Google Drive folder. I'll put a link to it in the description of this video. And that concludes this video of equations in isolation, guys. If you need any help, just drop a comment in the section below and I'll be sure to reply to those. Otherwise, stay safe.